Hi, and welcome to this continuation on the constructors and the contexts for decimals. So the first thing is I do my usual imports, so we'll execute that. Now let's take a look at the constructor. Now if you want, you can also obviously get the help on the console, and you can see that it tells us that construct has a new decimal object. The value can be an integer, a string, a tuple, or another decimal object. If no value is given, it returns a 0. Right? So if you just do a decimal with nothing in it, it will just be 0. So let's go ahead and try integers. So we can just look at decimal 10, and we just get back a decimal 10, right? So that's pretty straightforward when it comes to using integers. You can just pass in an integer, and you get exactly what you would expect. Now we can also use strings to do the constructor. So for the string, maybe, we do something like this, 10.1. And that will give us and construct a decimal object with a value of 10.1. And it will be precisely 10.1, unlike the floats, which are a little bit off. And you can do, negative numbers as well. So negative 3.1415. You just get that decimal object that gets created. So that's a pretty standard way of doing it using strings. Now you can also use tuples, as we saw in the lecture. And so let's take a look at how this would work with a tuple. Well, it's basically, you have to pass a single parameter, right? So the parameter that you need to pass in is a single value. So you have to be careful. The tuple has to be a tuple, right? So you can't pass in this. If you were building the tuple, right, t would be this. Let's say we want a positive number, so 0 for positive. Then the digits, let's do 31415. And let's say that we want 3.1415, so we have to put an exponent of -4. So this would be the tuple that we would use to create the decimal. And as you see, when we do that, the decimal is 3.1415. Now, I want to point out that if you're going to use this directly in the decimal constructor, you're going to have this kind of double opening brace and double closing parentheses, right? You need to keep that. You cannot pass it this way because that would not be a tuple, that would be 3 parameters. And so if you do that, you're told that, that's not going to work, right? So we have to pass it in this way, right? And there we go. And this works as well. So I just want to point that out. Sometimes it's a mistake that's easy to make. Now, and of course the tuple, you can do any number you want with it. If you wanted a negative value for that, right, you would just basically put in a -1 and, sorry, you put in a 1, not a -1. You put in a 1 to indicate that it's a negative value, right? So 1 for negative, 0 for positive, right? And then this, if you wanted 31.415, you would say -3 for the exponent and would get -31.415. So that's how we can use the constructor, the tuple variant of the constructor, to construct decimals. Now stay away from floats, because the problem with floats is that if we format 0.1 to, let's say, 25, then you'll notice that we don't exactly have 0.1. It's approximate. So even though we can do this, right, we can do that, but what are we actually passing into the decimal constructor? We're passing this number in. We're not passing 0.1 precisely. So if we do that, decimal is going to do its job and actually go ahead and construct this, which is behind the scenes what this number is. And that's probably not what we wanted, right? The whole idea was to get an exact. So in that case, you really have to use either the tuple, or what would be simpler in this case is just to use the string, right, to get decimal 01. And you can see that decimal 0.1 is not the same as decimal 0.1 created this way. We get a false, right? Now with integers, it doesn't matter, right? If we do decimal 10, will that be equal to decimal 10? Sure, right? Because the integer is an exact representation, so we're fine there, but not with floats. So stay away from floats when you're trying to construct decimals. That's probably not what you're trying to do. Okay, so now let's talk about the constructor in context of contexts, right? And so again, let's look at what our current default context is, which is our global context in this case, because we're at the module level. So we have a precision of 28 and a rounding of half even. So I'm going to change this global context, and I'm going to set the precision equal to 6, okay? So that means that we now have 6 digits for the precision. But this doesn't affect the constructor. So let's go ahead and try this. Let's say if I say a equals decimal 0.123456789, okay, which is definitely more than 6. Then if we look at what a is, we've retained all the digits that we specified, even though our precision was 6, right? So be careful with that. Just because you have a precision of 6, it doesn't affect the numbers that you're storing. It will affect the arithmetic operations. So let's look at something. Let's change the precision to 2, so I'll make it more extreme so it's easy to see what's going on. And I'll simplify this a little bit, and we'll do another one, as well. We'll make b equal to that, right? So now we have these two variables, a and b. And if we print a and b out, you'll see that they're both 0.12345, even though our precision was set to 2. Okay, now let's go ahead and add those two numbers. Now, if we were using just regular arithmetic on paper, right, if we added this together, what would we get? Well, we'd get 0.12345 plus 0.12345. I'm going to do it using floats, right? And I'm going to count on the display to just fix that up for me. It's 0.2469, right? 0.24690 if we were to add this, on paper. So that's the value that we're expecting. But now let's do a plus b. Let's see what we get. Well, we get 0.25. And now you can see that the precision that we set here too did affect the result, right? Because we had an arithmetic operation and it did the rounding. So 0.2469 was rounded to the closest, which would be 0.25. Okay. Now let's use the local context and show that the local context and the global context are independent of each other, right? So again, we'll just start with these two numbers. I'll repeat it here, I don't have to, but we'll print a plus b out. Then we're going to define a local context, so decimal local context as CTX, where you have to use the context manager. And what I'm going to do first, I'm going to reset the global context to 6. Okay, so that's 6. And we'll see what happens when we print a plus b out, right? Remember, our summation should be 0.2469. We'll see what happens. Now for the local context, I'm going to change the precision to 2. And I'm going to make c equal to a plus b. Okay, and I'm going to print, and I'll say c within the local context is, we'll just pass c in, right? So we'll print c within our local context. And remember, c was calculated within the local context. And let's go ahead and print c out, but once we've exited the local context. Now we're back to our global context, and we want to see if that makes a difference to c. So let's go ahead and run all that. And as you can see, when we print a plus b out in our global context, our default context here had a precision of 6, and here we go, 0.24690. So we had that precision. Now when we printed c within the local context, we only got 0.25. Well, that's because our precision was 2. Now when we exited the local context, and now we're back within the global context, the value for c is still 0.25. And of course that has to be because c is 0.25. There's nothing that's kind of magical about this where it actually stores extra digits for c. No, c was exactly 0.25, so it doesn't matter what context you're in, it's still going to be 0.25. You're not going to magically get, 0.24690 once you exit the local context because you created c within that local context. So just be careful with that. Don't think that this is just a display mechanism. It's not. It's actually a calculation mechanism that affects your arithmetic operations. But the precision does not affect the precision of the constructor, right? So I may have a precision of 2, but I can store digits with a lot more precision. That's fine. But if I do calculations with them, that's when the precision is affected. All right, thanks for watching, and I'll see you in the next video.